Alright, so we are in AP Stat. We are in Chapter 4, and we are just going to go over some practice problems. This is in Unit 1. Displaying and summarizing quantitative data practice problems is basically what I'm trying to get you to look at here. So, take a look at this one. This is a histogram, and it displays the sugar content of 49 brands of breakfast cereals. And we're supposed to describe the distribution by what it looks like. What do you think might account for this shape as well? So as you're looking at the shape, it's kind of looking like we have two big chunks here. It kind of looks like describing the distribution. That's where they want us to describe what we call like socks. Like, how does it look? What's the shape? What's the spread? Is it skewed? Are there outliers? What's the center? Things like that. So the distribution of the sugar content of breakfast cereals looks bimodal. Bimodal meaning we got one hump here and another one, two of them, two modes, with a cluster of cereals with sugar content around this like 10-ish percent mark, and then the other cluster is around this like 48-ish around in here percentage mark. The lower cluster shows a bit of skew, right? This cluster, right? If you look at it, kind of looks skewed to the right. This one kind of looks, if anything, maybe skewed to the left, but kind of normal. Most cereal in the lower cluster is between 0 to 10%, and the upper cluster kind of looks more normal and symmetric. With that center, it could be in between like the 44, 48-ish, so around 45 mark is what it's kind of looking like right now. And what do I think might account for that shape? Well, there are two different types of breakfast cereals for the most part, those for kids and those for adults. I think we can all kind of verify that. And the children's cereals are likely to have a higher sugar content, more than likely. So thus, these are probably the breakfast cereals for kids, making them taste better. And adult cereals probably have the lower sugar content in them. Take a look at this one. Histogram shows the sizes of 36 vineyards in the Finger Lakes. Okay, approximately what percentage of these vineyards are under 60 acres? All right, so that's the number of vineyards, and this is the size of acres. So under 60 acres. So if we were to chop this up, it looks like it's 1, 2, 3. That looks like it's 4. There's 5. So if I was to say under 60, I'm going, that's 15. I'm going with, gosh, maybe 13. So that's 28. So, I mean, like I'm trying to find like roughly the percentages of them, of the 60. So trying to scan it down, you're looking at it to see, and it goes, information displayed about 36 of these, right? If we're trying to cut it into 36. It appears that 28 of them are smaller than 60 acres, right? Because right here, if I'm going across, 1, 2, 3, 4, if I split it into 4s, that looks like it's 30, 60. So if that's about 60, it's looking like maybe it's in that 28 range of the vineyards or less than that, all right? And then it says the distribution of the sizes is skewed to the right, most definitely skewed to the right. Most vineyards are smaller than 75, because if that's 60, that's 90. So once you get it to 90, there's barely any. So it's somewhere in between here, the 60 and there, that they start getting a little fewer. From 90 to 160, there's very little at all. In the wine vineyard, they had that one large one that's kind of like an outlier more than anything. If you were to go with the mode, it's probably somewhere in between the 0 and 30, right? Seems to be our mode for that one. Taking a look at this one, histogram shows the lengths of hospital stays in days for all the female patients admitted to a hospital in New York during 1 year from a primary diagnosis of some type of heart attack. From the histogram, would you expect the mean or the median to be larger? Since this looks skewed to the right to me, that means if it's skewed to the right, it's pulling my mean down this way. So that means my median, I think, my guess would be higher. If I was to describe my socks or my shape, my center, my outliers, my spread, like if I was to do all that, definitely looks skewed kind of to the right, like we said. Looking at the spread of where things are all chunked and summarize the data. So let's take a look here. Definitely skewed right, so the mean is definitely larger. And the distribution of the hospital stays is definitely skewed to the right. Going with our range of data, it looks like that's about 1 to maybe 36, 37, right? So subtract and find the range. The distribution is centered around 8 days, because if we were to go with the mean being pulled down this way, where does the middle appear to be of the number of patients? And my point is, like, it looks somewhere around in here, if I were to find it, and I could try to chop this all up to figure out exactly where the mean is, or sorry, the middle is. And the distribution is centered probably around 8 days, because there's 5, 6, 7, 8. It's probably right around in there. And all that, if you were to throw it together, would probably even out to be right in the middle. There are also relatively few hospital stays that are more than 27 days, right? Once we get around this 25 mark, everything starts to dwindle out. And many patients have a stay of only 1 day, right? That seems to be kind of the max there. We have, it's probably close to a week, is where that is. And then possibly because the patients will die. That could be one option as to why it's only a 1 day stay, and that's pretty high up there, and it's also pretty morbid to think about. Taking a look at part C, it says, which summary statistics would you choose to summarize the spread of the data? So they're asking your opinion. The median, because it's getting pulled down by an outliner, so I would do that one, and the interquartile range would be used to summarize this, since the distribution is strongly skewed. So we want to cut out those outliers and mainly look at the interquartile range of those. Taking a look at this, the display shows the average drive distance for 202 professional golfers on the tour, and the drive being how far they can hit it. And it kind of looks pretty normal for the most part, right? It doesn't look too skewed overly in one direction or another, so it looks pretty normal, with the middle, for the most part, probably being somewhere around in the 285, 290 range, probably, is where the middle is, with no real outliers. And the spread as well is probably, the low is around 255-ish, maybe, to 320. What proportion of professional male golf drivers on average less than 280, right? So if we were trying to cut it down to percents, you could try to break this up, since this is the number of them total, since there is 202 of them, and they want to know the 280, less than 280, you could roughly guess there's 20, there's less than 10 maybe total there, so you can add them all up. You can estimate the mean by examining the histogram to see. So let's see what we got here. The distribution is roughly unimodal, right? One lump there, kind of normal, with a typical drive somewhere in the midst of 280 to 290, somewhere in there. Professional golfers on the men's PGA Tour had drivers that were definitely shorter, around that 260 and up to 320. Approximately 15% of the male golfers drive less than 280 yards. The main reason, my main guess, is that here's 280 out of the 202 golfers. That's about 20, about 5, maybe 3 to 4, and then a 1. So add those all up and divide by the 202. It's about 15% are less than that. The mean, though, estimate the mean, because it's normal, right? If it's unimodal and it's normal, the mean is probably going to be somewhere in the middle, and somewhere in the middle would be, in between that 85 to 290, but an estimate would be there. The actual mean is this. You could add all these up. Basically, a 255 drive happened once. You would say that a 265-ish happened about, you could add these all up. The 275 to 280 drive happened about 20 times. So, you could take it and you can add them all up and get it the long way. But if you were to estimate, because it's unimodal, it looks like the median and the mean are about the same together, pretty dang close. So it's probably in between 285 to 290. And then what does it ask for D? Do you expect the mean to be smaller than, approximately equal to, or larger than the mean? And then the actual mean is 288.6. So an estimate between that, we did that one right here. The distribution of golf drives is approximately symmetric. And because it's unimodal and symmetric there, and it looks kind of normal, the mean and the median should be relatively close to one another. The actual median, if you were to cut this stuff and look at it, would be 288.35. The point is, it's something you should assume, that when you do these, the middle, the median, right, the normal distribution, it's all right there, right smack dab in the center, if this all works out together. All right. Taking a look-see through this, I'll actually stop here so we don't have to get stuck in the middle of the problem. But we'll take a look when we come back, and it wants us to generate a stem and leaf plot of that data.